Before you begin Physics 111, and I've already pointed this out in another video, but you should definitely check out the background material. So this is really important to make sure that the concepts that I'll be talking about are familiar to you and that you understand them, and to identify anything that you may want to ask me either during discussion sessions or in the team's Physics 111 discussion channels. The other thing that's very important is to recap something that's on the lecture notes about exponential functions, and even more importantly about logarithmic functions. So if you don't remember, an exponential function is very simply given by the value of the function when x equals 0, e to the power typically of kx. And typically we use this k or r rate, whatever you want, and when k is higher than 0 we have exponential growth, and whenever k is below 0 we have an exponential decay. So this is crucial, for example, to describe radioactive decay. Now, in many cases, what you actually want is to invert this function. You should know that the inverse of the exponential is the log. So you can have a look at functions that look like y equals log of some base a x, and that if you take a to the power of log a x, you retrieve x. And same way, if you take the log base a of a to the power of log a x, you also retrieve x. Properties like these should be something you're familiar with, and if not, make sure you recap them. The other thing that's important is to do with the properties of logarithms. And specifically, and I'll try to demonstrate the magic of Physics 101. Well, maybe this is too much, so let's rewind. There are important properties of logarithms that if you don't know, you should recap, which have to do with taking the log of product, log of a quotient, or log of a power law. First thing is log of a times b is the same as the sum of the logs. Log a plus log a b. Now, for the quotient of quantity is very similar, but they have a minus. So log a of a over b is the same as the difference. And finally, and this is an important one for a lot of demonstrations, and also even to demonstrate how you can change base from base a to b, is taking the log. We're just keeping it general. Lecture notes will have more details and being specific about base 10 and base e, which is the natural logarithm. Log a of a to the power of b is the same as taking it as a constant out, and this is b log a of a. Now this is actually the property that you need in case you want to go from log a of x to log b of x. With logarithms, sometimes you do want to change base from, say, a base a to a base b. And for that, you can either know the formula of how you do that, or if you know this property of logarithms, it's actually quite simple to find it. So let's try it. So one thing you can start with is understanding that if you take a to the power of log a x, you get x. So let's take the logarithm of base b on both sides. Now, as the next step, let's use some physics 111 magic to get rid of this, right? Do you remember? So we now have space to write it up. So all we need to understand is that we can take this part, a to the power of log ax, outside. It's now been multiplied by log b of a, and this equals log b of x. So if you want to go from log a of x to log b of x, all you have to do is apply this. If you don't remember, you can always start with something like this, apply what you know about logarithms, and derive it. And I think it is important that in Physics 111, the crucial aspect is not to memorize formula, but actually to practice, so you can obtain them, provided that you know the basic mathematical tools and that you practice a lot. Now let's make something even cooler, which is trying to make things disappear from the boards with a specific frequency. Maybe that worked. How about this one? What about this one? And maybe this one? So it looks like we're ready to continue with Physics 101.